graphing quadratic reciprocals. Essentially, this is a quadratic function, and the original quadratic, which is this f at x, can actually give us quite a bit of information about the quadratic reciprocal. So first what we'll do is we'll write out our quadratic reciprocal. We'll call it h at x, so it's a function of h. And essentially the reciprocal is the idea of this function over 1, and then we just invert the denominator and the numerator. So we now have 1 over x squared minus 2x minus 8. Okay. So with our quadratic, I'm going to factor it. We're going to do the original one here. This one's a pretty simple one to factor. You can kind of just use the product sum rule, and this will factor into x minus 4, x plus 2. Are you okay with how I?
Yeah.
Yeah? Okay. Because I can go more into depth in that. If you don't remember, just let me know. But these are essentially, this was kind of the standard form, and this is the factored form. The factored form is very important in a reciprocal function because we need to know on the bottom essentially what values will create a 0. So we're going to change this standard form into the factored form now. So now we're going to focus strictly on the reciprocal. So I'm going to bring it down here. H at x is equal to 1 over, and now we put it in factored form. We have our x minus 4, x plus 2. Now, the reason it's important to find out these values, because these values, we're going to set them equal to 0. And the reason being is because if we ever have 1 divided by something, that's essentially undefined. We can't do that. So this is where we're finding vertical asymptotes. So what we need to do is I need to set x minus 4 equal to 0, and I need to set x plus 2 equal to 0. So when we do that, we get, actually I won't even do it below, I'll do it on the side here. X minus 4 equals 0 means x equals 4. But really what we're saying is x cannot equal 4. 4 cannot be one of the values when we're graphing that. Same concept of x plus 2 equals 0. X, when we bring 2 over, is negative 2. But again, what we're saying is x cannot equal 2. So those are two of the restrictions on this. If we plug those values in, we get 1 divided by 0. This is an undefined idea. Okay, so in the general sketch of this, okay, so we have our Cartesian plane here. What that means is at negative 2, so we'll say this is, can I get all the way up to positive 4? Yeah, I can. Okay, great. So here at negative 2, we essentially have a vertical asymptote. So the graph doesn't touch that. And then the same idea again here at 4, same concept happening. We have another vertical asymptote at 4. Okay. So what that means is whatever's happening in this function, it's doing something like this, maybe going like this after. Could be something in the middle. We're not quite sure. But we know we're not touching these lines, okay? Now, with that being said, there possibly is a horizontal asymptote. Now, vertical asymptotes are absolute. You'll never cross a vertical asymptote. At least I haven't encountered it. There are points where you'll cross horizontal asymptotes, but most likely with what we're doing here, you won't. One of the ways to find a horizontal asymptote is the idea of when a function is approaching infinity. As our x value gets very close to infinity, is where you'll essentially find a horizontal asymptote. Essentially, the y value is getting really, really close to the value that it can't touch. So, with that being said, I'm going to take this function here. Okay, so I'm going to find h at infinity. So we get 1 over infinity minus 4. Infinity plus 2. Okay. Infinity minus 4 is essentially infinity. And infinity plus 2 is essentially infinity, which leaves us with infinity times infinity, again, infinity. So 1 divided by infinity. So we have to get this idea across here because it's not exact, but it's very, very close. Think of this as 1 divided by an infinitely large number. In other words, let's kind of play with our calculator here at the time. 1 divided by 10,000 is a super small decimal. And then as that number gets even larger, let's see how far we can go in this. Whoa, this is a great calculator. Whoa, okay, that's good enough. You see how very, very, very small this number is, right? So the idea is it is, in all practicality, this number is 0. So what we'll say here is it is approximately 0. So in other words, we're saying the horizontal asymptote is when y is approximately 0. So I'm going to put another, we'll put it in blue this time. We have a horizontal asymptote here. Okay, so in other words, the graph is most likely not crossing this point. So maybe it's doing something like this, and then like this, but it's not crossing. Or vice versa, it could be doing like that. We don't really know what's happening yet. Okay, so now that we've done that, we can get some of the general points. We have our vertical asymptotes, we have our horizontal asymptote. We'll kind of denote them here as our vertical asymptotes. This is where we found our horizontal asymptote. Now what we're going to do is essentially find values. And this factor form is going to be really helpful for it. We want to know our y value since we know 0 is the cutoff. When we're at an x value that's less than -2, maybe like -5, are we positive or are we negative? And then between -2 and 4, are we positive, so above the horizontal asymptote, or are we negative? And then greater than 4, like a value of 5, are we positive above the horizontal asymptote or negative? Okay, so we can kind of build like a number line down here to solve that. I'll put our little number line out. Numbers on both ends. Okay, so this is where our vertical asymptotes are important. We have -2 and +4. We know that we don't exist at those values. So what I'm going to do is I'm going to choose a number less than -2. I'm going to say -5. And we're going to plug it into the equation to find out are we positive or negative. We're going to choose a value between -2 and 4. I'm going to choose 0 just because it's going to do something else for us also. It's also a pretty easy number to work with. And then 4 again, I'm just going to use +5 because those are all values that are less than. So here we are less than -2. Here x is less than 4 but greater than -2. Okay. And here x is greater than the value of 4. So that's what we're kind of working with right now. So what we're going to do is plug those values into our reciprocal function. So h at, the first one we're going to look at, h at -5 is equal to 1 over, I'm going to remember the function.
Is that like the sign chart, kind of?
Yeah, very similar to that, yeah. So x minus 4, x plus 2. So in this case, I'm just going to write it down, x minus 4, x plus 2, so I don't forget. So this becomes a -5 minus 4, -5 plus 2. Now, the value is wonderful. It gives us a coordinate, but really what we can do here is I only really need to know if it's positive or negative. So I have 1 over, that's going to be a negative, that's going to be a negative. A negative times a negative is a positive. So this is a positive divided by a positive. I know my value is positive. Now, obviously, it's not that hard. We could have actually got the exact value, but just for argument's sake, I just want to show you. All we're really looking for here is, because we're doing a general sketch, we know our value is positive. So if we're positive, that means this graph, because here's our horizontal asymptote, it's very close to it, and it's above it, and then at the vertical asymptote, it heads upwards. Okay, so that positive tells us that we're in this range here. Our 0 value, so when h is 0, okay, 1 over, we get 0 minus 4, and 0 plus 2. Now, this coordinate is important, but I'm still going to do the same idea, and then we'll calculate it after. This will gives us a negative. This is a positive on top. This is a positive here. So now we're going to get a positive. Negative times positive is a negative. Positive divide negative is a negative. So our answer is going to be negative here. So we have a negative answer. So that means it's coming up, it does something, and then it's coming back down, never really crossing that horizontal asymptote. Okay, and then finally, we can probably estimate, but we might as well do it just to make sure. H at 5. We have a positive on top. 5 minus 4 will be positive 1. 5 plus 2 will be positive, so obviously we end up with a positive value. Okay, so again, that's telling us that we're now coming down and we stay above that horizontal asymptote. So here's the general idea of our graph. The reason 0 was kind of important is because it tells us the y-intercept, so we can get an actual coordinate. So if we actually went about solving this, that would have been 1 over -4 times positive 2, 1 over -8. So -1/8. So at 0, we have a 0 and -1/8. That's a 2. -1/8. That's a coordinate there. Okay. Sometimes your teachers will ask for like 5 major points, and a way to do that is to kind of set your y value, especially if your horizontal asymptote's at 0, set your y value to 1. So we say 1 equals, and then solve for values of x. So there's kind of some isolation and stuff like that. But this would just be general sketching. Your teacher might not ask that. You could also just plug in like here's a coordinate, here's a coordinate, here's a coordinate, another point, and then you have 5 points. There's a couple different ways to do it. That's the simplest one. let's check to make sure all our answers are right and get some other important information. So our original quadratic was x squared minus 2x minus 8. Okay, so here's the original quadratic. Remember, negative 2 and positive 4, those are actually important in our reciprocal. Copy this, Control C, 1 divided by that function. Those are, we can zoom in a little, those are our vertical asymptotes. We'll zoom out just a bit, okay? Our y-intercept, 1 over 8 is roughly that value. We have a vertical, so x is equal to negative 2. That is a vertical asymptote there. We found that. X is equal to 4. Make it orange again, dot it. There's our other vertical asymptote. And technically at y is equal to 0, we have a horizontal asymptote. And we can kind of zoom in and see it never really touches that value. But we can kind of assume from there. So that would be the general sketching. And again, if you want points that are important, there's our y-intercept. Because there's a horizontal asymptote, there's no x-intercepts. If the horizontal asymptote was at a different value, x-intercepts could be kind of the points your teachers are looking for, but in this case, there are no x-intercepts. So we have a y-intercept, and then just major points along that. Sometimes teachers really like values that are 1 to the right and 1 to the left of vertical asymptote. So like, what's your 3 value, right? So negative 3 and 7. You could just plug negative 3 in to find it if you want. Negative 1 is at negative 1 and 5. We could just plug negative 1 to get in. So sometimes they're looking for values that are 1 to the left and 1 to the right. So that'd give you 1, 2, 3, 4 major points, and we have a y-intercept. There's 5, but again, it's what your teacher's expecting of you. Okay.